Hello, I will talk to you about the algorithm called PFPM to discover the periodic frequent patterns in a database. Let me give you a brief introduction. There's a very popular data mining task called frequent item set mining. The goal of frequent item set mining is to discover some set of items or values that appear many times in a database, or we say a database of transactions. Okay, so it has many applications in different domains. So for example, if we have a database of what the people buy in a store, we can find that maybe tomato, wine and cheese is a frequent item set. It is a set of items that many people buy together. So if we find the frequent item set, it can be very useful. If we know that people buy this often together, then maybe we can do some promotion to try to earn more money and so on. So there have been a lot of work about frequent item set mining. So let me now talk to you in more details about this. So in frequent item set mining, we have the data is the format of the data is a transaction database. As you can see here, it is a database of transactions. Here we have 7 transactions, T1 to T7, and the first transactions means that some people have bought some items A and C together, like apple and cereal. Another transaction, T2, some people has bought an item E, like eggs. Then in T3, some people buy A, B, C, D, E, and so on. So we might have a database like this, we call it transaction database, about shopping. Or actually, it could be other things. There are many things that we can represent with a database. Actually, A, B, C, D, E are some symbols. It does not need to be about shopping. It could be about web page or about text document and so on. So in frequent item set mining, we want to find the item sets, the sets of items that appear often. We use a measure called the support or frequency of an item set. It is the number of transactions where the item set appears. So for example, if you look at the item set A and C together, it has a support of 4 transactions because A and C appear in 4 transactions together. 1, 2, 3, 4. Okay. Now, in frequent item set mining, how it works? We have the input. The input is transaction database, and the user also need to set parameter called the minimum support. It must be set to value greater or equal to 1. And the output is the set of all frequent item set, all the groups of items that appear in at least min-sub transactions. So for example, if you set min-sub to 2, that means you want to find all the sets of items that appear at least twice in the database. Let me show you this with an example. So here I have a database, again, transaction database, and we set the minimum support to 2. So we want to find all the sets of items that are purchased together at least twice. So this is one part of the result. We find that BDE together appear twice as a support of 2. So BDE appear in T4, transaction 4, and appear in transaction 1. So the support is 2. DE has a support of 3 because they appear here, and here in T1, T3, and T4. So in frequent item set mining, we find all these item sets that appear at least min-sub time, where min-sub is a parameter set by the user. So it is a type of problem where we have an input and there's always only one solution. We want to find the solution. Okay, so how to solve this problem? There have been a lot of work on this. There's a naive approach. The naive approach is to scan the database, read the database to count the frequency of each possible item set. So for example, if we have the items A, B, C, D, E, all the possibilities are A, AB, AC, AD, AE, ABC, ABD, and so on. So all the combinations actually. So if we have an item like 5, ABCD, there are 2 to the power of 5 minus 1 possible item set. It's not so much, so we can calculate all of them. But imagine we have a store with 10,000 items. That means there are 2 to the power of 10,000 minus 1 possibilities. So if we use a naive approach, we calculate the support of all the possibilities. It will take a lot of time. It will be inefficient. So there are many algorithms. They solve this problem by using some special structure or strategy to avoid looking at all the possibilities. Some popular algorithms are Apriori, FP growth, HMINE, LCM, and so on. So how they work, I want to give you some explanation. Most of them, they use a very famous property. It is called the Apriori property or anti-monotonicity. So what does it say? It says if you have two item sets X and Y, such that X is a subset of Y, so X may be like AB and Y ABC, then the support of Y is less than or equal to the support of X. So let me explain this with an example. If we have an item set like AB, it appears 3 times. The property means that any superset of AB like ABC cannot appear more than 3 times. The support of ABC cannot be more than the support of AB. It must be equal or less. So actually it makes sense. If the support of AB is 3, AB appears 3 times, then if you add something else, like C, to get ABC, of course ABC cannot appear more often than AB, because we have also C. Okay, so this is the goal of this property. It's very powerful to reduce the search. So for example, if we set the minimum support to 2, and we find that ABC appear maybe only once, we know that all the superset of ABC cannot appear more than once, and we don't need to look at all of them, so the algorithm will be faster. Okay, so there are some limitations to frequent item set mining. Actually, although it has many applications, it is not designed to find the periodic patterns. What is periodic pattern? Here we mean some patterns that always appear over time, repeat itself over time. So we want to find some patterns. For example, every week some people will buy the wine. It is something, if we find this, maybe it's very useful. Okay. So let me give you some introduction about periodic frequent pattern mining. There have been a few papers about this. The goal is to find a group of items or item sets that appear periodically in a sequence of transactions. So we have transactions with time, and we want to find some patterns that repeat itself over time, many times. It has various applications. So for example, maybe we find that in the shopping data, some people buy some baguette, some bread, cheese and orange juice every week, for example. So it will be a periodic pattern, repeat itself every week. So if we find this is useful, maybe we can do a promotion or give a discount if the customer come back every week to buy this, for example. So there have been a few papers about finding the periodic frequent patterns. Generally, they say that pattern is periodic if it has no period greater than some maximum threshold. So what is a period? A period, that means the time between two occurrences of the item set. So for example, if you have an item like wine or apple, then apple appear every week. So that means the period is 1 week, for example. Between two occurrences where the people buy it, we say the period is 1 week or 2 weeks, for example. So a pattern is periodic if it has no period greater than some maximum. That means if we set the maximum to 1 week, we want to find the patterns is about at least every week. Maybe more often, but never more than after 1 week. Okay. So this definition has been used in many papers, but there's a big problem with this. The definition is very strict. For example, if you set the maximum to 1 week, a pattern can be discarded if it has a single period greater than the threshold. So for example, you have the pattern appear almost every week, but only once it appears every 2 weeks. And then, because of this, the algorithm will not find it, although it appears almost every week. So we think that this is too strict. So the solution in this paper is to introduce some new measure called the average periodicity and the minimum periodicity. So we don't want to be very strict, but we want to use the average. So on average, we want to find patterns the people buy every week. Maybe sometimes it's not every week. So this will be more flexible and can find maybe the more interesting patterns, also more patterns that we cannot find otherwise. So we present an algorithm also in this paper called PFPM to find these patterns. So let me first give you some more formal definition. Okay. About the period of an item set, I want to give you a formal definition. The period of an item set is the number of transactions between two consecutive occurrences of the item set. So if we look at A and C together, for example, here we have A and C appear in the first transaction. We suppose the transactions are ordered by the time, from T1 to T7, one after the other in time. Okay, so AC appear in the first transaction. This is a special case. We suppose that maybe AC appeared before. So we say that the period is 1. It appeared one transaction before maybe and one after. Then AC appear again 2 transactions later in T3. So we say the period is 2. Then it appeared 2 transactions later in AC, in transaction 5. So we say the period is 2 again. Then AC appear 1 transaction later, so we say the period is 1. And then it appear more than 1 transaction later, but this is a special case because it's the end of the database, so we say still it is 1. So the periods of AC are 1, 2, 2, 1, 1, 1, 2, 2, 1, 1. So on overall, we can say that the maximum periodicity of AC is 2. That means AC never appear after more than 2 transactions. For example, AC is about at least every 2 weeks if there's 1 transaction every week, for example. So here in my example, I didn't use the time. I just used the number of transactions, but we could change the algorithm also to use the time instead, the exact time, like hours or days. So in a periodic frequent pattern in other paper is a pattern that has a support and maximum periodicity that are not a support that is smaller than the minimum support and a maximum periodicity that is smaller than a maximum periodicity threshold. Okay, so I show you some example with the database that I showed you just before. Okay, so here we have some patterns and I calculated the support, like AC appear 4 times in the database. And here we have the maximum periodicity, the measure we use by other papers. So we find that AC appear at least every 2 weeks. We find also that E, item set E, appear at least every 2 weeks. And then in our paper we propose 2 new measures, the minimum periodicity and the average. So that means AC is about at least the minimum, the smallest amount of time between 2 occurrences of AC is 1 transaction. The maximum is 2 and the average AC appear every 1.4 transaction. So why it is useful to use the average? Because if you look carefully, like AC and E, both of them have the same maximum, the same minimum. But if you look at the average, you see they are different. AC is about every 1.4 transaction, but E is about every 1.1. So using more measure, we can get a better idea of whether a pattern is periodic. That's why in this paper, instead of using only 1 measure, we use 3 measures on the periodicity of patterns. So we can maybe more control, more precisely the patterns that we want to find. So we define the problem as follows. We give a new definition. The goal is to find all the patterns, each pattern X, such that the average period of X is greater or equal than some minimum and smaller than some maximum. So for example, X on average is about every 1 week at least, but less than every month, for example, on average. And we want the minimum periodicity of X to be greater than some minimum and the maximum to be smaller than some maximum. So here we have 4 parameters. It is actually more parameters than before, but we give more control to the user to find the patterns that the user really want in terms of periodic patterns. So in the paper presenting these algorithms, we also study the property of this problem. We define some lemma in the theorems, okay, about this measure. So we find some interesting property like about the average periodicity. If we have two item set x and y, x is a subset of y, we can prove that average periodicity of y must be greater or equal to that of x. There's other similar property for the minimum periodicity and so on. So why we find this property? Because, as I said before, we don't want to look at all the possibilities. We want to reduce the search for the patterns. So we use all these properties to try to reduce the search, actually. Okay, so we have here two theorems to reduce the search. Theorem 1 actually is the same as in previous paper. It's not something new. But theorem 2 is something new. If we have an item set x and the average periodicity of x is greater than the maximum, we don't need to look at all the supersets of x. So this is very useful. If you find AB, the average periodicity is greater than the maximum threshold, you don't need to look at all the superset of AB. You can save a lot of time to find the result. So how it works, the algorithm PFPM. PFPM is for Periodic Frequent Pattern Miner. It do a depth first search. It will start from the single item like A, B, C, D, and then recursively it will append some items to them to find larger item set. Like from A, we do AB, then we add C, ABC, then ABCD, ABCD, and so on. And then we will look at all the possibilities. And of course, we don't want to look at all the possibilities. So also we apply the theorem 1 and 2 to try to reduce the search. Don't look at all the pattern to make it efficient. So I give you a little bit more details. Actually, I don't want to explain the whole algorithm because it will take more time, but you can see more details in the paper if you are interested. Yeah, I just want to give the main idea. So actually the algorithm is extend the ECLAT algorithm for frequent item set mining, but we add we modify ECLAT to find the periodic pattern with our new measure. In the ECLAT algorithm, each pattern like AC, item set like AC, will have a structure we call the TID list. That means the list of transactions that contain AC. We'll calculate this. So what is interesting, if we have this list like AC appearing T1, T3, T5, T6, we can quickly calculate all the periods of the pattern AC. Then we can calculate our periodicity measure. So it's very useful to use to change the ECLAT algorithm because the structure we use, the TID list, is very good for calculating the periodicity. So again, I will not talk about this in details. You can see in the paper. So this is the code of the algorithm in the paper actually. Again, I will not explain this, so if you want more details, you can have a look at the paper for how it works. Actually, it's very simple. Not very simple, but not difficult. Okay, so let me talk to you about some experiment we did to evaluate our algorithm. We use 4 databases used in other paper for frequent item set mining. Retail, chain store, food mart are shopping database, and mushroom is a database about mushroom. It's not really relevant, mushroom, for our algorithm, but it is useful to test the algorithm because it's a standard benchmark database and it has different characteristics. So all our database have different characteristics to see how the algorithm works on different kinds of data. So retail has 80,000 transactions, 16,000 different items, and the average transaction length is about 10. And other database is different, so we can see different type of data. So in our experiment, we compare PFPM, our new algorithm, to find the periodic pattern, with ECLAT to find the frequent item set. So why ECLAT? Because our algorithm extends ECLAT, so it's normal to compare with them to see if we find only the periodic pattern, will it be faster? Can we find less patterns? So we compare these two algorithms. One thing we need to say, our algorithm only finds the periodic pattern, but ECLAT will find all the frequent item sets. So our algorithm will always find less patterns than eclat, because we only keep the periodic, we don't keep all the others. So obviously our algorithm will always find less patterns than eclat in general, and sometimes it will be faster, maybe sometimes not. So we use Java, Windows 7, 5 GB of RAM, and we did some experiment. I will show you. So first we evaluate the execution time. We use the retail, mushroom, chain store, FoodMart database. For retail, we have a chart like this. We have a parameter we change the maximum average periodicity, and we have the runtime. We want to change the parameter to see the runtime, what's the difference. Then we compare eclat to find the frequent item set with our algorithm called PFPM. For PFPM, we call PFPM 1005. What does it mean? Here I explain. PFPM VWX means the minimum period, the maximum period, and the minimum average. So PFPM 1005, that means PFPM with minimum periodicity 1, maximum periodicity 1000, and minimum average to 5. And then the maximum average we change on the axis here. So we have different parameters for our algorithm, and we can see here our algorithm is faster. Why? Because faster than eclat, because we find only the periodic patterns, so we can eliminate many patterns that are not periodic using our new theorem 2, and then it can be faster because of this. On other database like FoodMart, eclat can still be faster than our algorithm. The reason here why eclat is faster, because our algorithm needs to calculate the periodicity, but eclat does not. And in this pattern, there are not so many periodic patterns, so it is possible that eclat is faster in some case. In other cases, like in mushroom, eclat took too much time, so we did not show it in the chart here actually, or it ran out of time or memory, so the result is not there. But we can see that when we change the parameter of our algorithm, it can change the speed quite a lot, okay, depending if we want to find, we change the maximum actually from 1500 to 50, it will change the speed. It will become faster if we don't need to look at all the patterns. We also look at the number of patterns in the database. Here we change again the parameters, and we find that if we find all the item set on retail, maybe there are 10,000 patterns. But if we find only the periodic pattern for these parameters, we find less than 100 patterns. So that means there's a lot of patterns in this database that are not periodic. So using our new algorithm, we can filter many patterns that are not periodic. So that means it's useful actually. We can focus on the periodic pattern and ignore many patterns that are not periodic, if it is what we want, of course. Okay, so we also look at the patterns that we found. We find in retail some interesting patterns, like some products like 32, 48, and 39. It is some products. I don't know exactly what they are, but we find that these products are bought with average periodicity of 16, a minimum of 1, and a maximum of 170. So that means in this database, we have many customers together in the database, and we find that overall, every 16 transactions, there will be one customer that buys these products together. So that means it's some very popular products. Okay, so one limitation about our experiment is that in the retail database, all the customers are together in the database. It will be interesting to also use the database for each customer to see the behavior, the periodic behavior of each customer, but we did not have the data for this. We also find that our algorithm can use less memory than eclat in some cases, up to 4 or 5 times. Okay, so in conclusion, the PFPM algorithm is a new algorithm to find the periodic patterns. We propose 2 new measures, the average and minimum periodicity, to give more control to the user, and a new algorithm, PFPM. We did some experiment. We find that we can eliminate many non-periodic patterns, and it is much faster than eclat in many cases. The source code and data set of the algorithm are free. You can use as open source in our software called SPMF. It has more than 100 algorithms for pattern mining, for item set, association rules, sequential patterns, and so on. So if you want to use this in your research, either to change the algorithm or to apply it to some new application, it's free. There's some example. You can see the code, you can change the code, you can have all the data that we use in our experiment. You can use it in your research or your application if you want. It's completely free. So if you want, you can have a look at the website, or if it's too long to type, you can just search SPMF in the search engine and you will find our software and you can look at the code. So that was my presentation of this algorithm. I hope it was clear. There's other video also on the SPMF website. If you're interested, you can watch the other videos, or you can also leave some comments in our forum on the website and so on. Okay, thank you.